Hello, what's going on, Grecians? This is Sir Eman and welcome back to another episode of The Scientific Mind. Today we are going to discuss topics related to biodiversity. But before that, let's have a prayer first. Before we proceed to our main discussion, I will show you the worksheets that you are going to do for this week. On the first day after watching this video, you are going to answer activity entitled Index of Diversity. So you need pencil and paper in this worksheet. Procedure: determine the index diversity of the flower community using the Simpson's Index of Diversity formula. So you have 4 flower species, namely Gladiolus, Narcissus, Primrose, and Aster. After you have determined the index diversity of the flower community, you are going to answer 2 guide questions. On the second day, you are going to answer this worksheet entitled Measuring Population Density. So you need a ruler, pencil, and paper and this worksheet. You will get the population density of the 4 species of flower. The flower density of Gladiolus, the population density of Narcissus, population density of Primrose, and the population density of Daffodil. After you have completed and recorded it in this table, you are going to answer 6 guide questions. On the third day, you are going to answer this worksheet after you watch the video about species extinction. In this activity, you will predict what you will see in an island with human and without human. You can list up to 15 things or predictions. After that, you are going to answer these 2 guide questions. On the fourth day, you will open your book on page 91 to 92 and answer concept mastery, multiple choice, and the apply what you know type. Make sure that you answer those activity before the deadline. Now that I have given you the activity or the worksheets that you need to accomplish, we will proceed now to our discussion. Species population. What is species? A species is a group of organisms that can reproduce with one another in nature and produce fertile offspring. Species are characterized by the fact that they are reproductively isolated from other groups, which means that the organisms in one species are incapable of reproducing with organisms in another species. The term species can also be defined as the most basic category in the system of taxonomy. Taxonomy is a scientific system that classifies organisms into categories based on their biological characteristics. The other categories that falls under the taxonomy of organism includes kingdom, phylum, class, order, family, and genus. Species can also be defined based on a shared evolutionary history and ancestry. Phylogenetics is the study of evolutionary relationships among organisms. The evolutionary process by which a new species comes into being is called speciation. population. Population is the number of organisms of the same species that live in a particular geographic area at the same time with the capability of interbreeding. Population can occur on various different scales. For example, a local population can be confined on a spatially small area. For example, a fish in one pond. However, this locality can operate on a regional, countrywide, island or continental scale. It may even make up the entire species. Biological diversity, also known as biodiversity. Biodiversity is the variety or the variability of life on Earth. Biodiversity is typically a measure of variation at the genetic, species, and ecosystem level. Biodiversity can be quantified in many different ways. The two main factors that ecologists take into account are species richness and species evenness. Species richness. So what is species richness? It is the measure of the number of different kinds of organisms present in a particular area. Species richness is also a simple count of the species in a community. Each species contributes one count to the total regardless whether the species population is 1 or 1 million. Okay, let's use this example. A flower species counts from two communities. There are 3 species of flower: daisy, dandelion, and buttercup. And we have communities, community 1 and 2. The number of individuals of flower species daisy, dandelion, buttercup in community 1 is 300, 335, and 365 respectively. While for community 2, the number of daisy, dandelion, and buttercup is 20, 49, and 931 respectively. So what is the species richness for the two flower communities? For community 1 and 2, they have the same species richness, which is equal to 3. Species evenness. It is the measure of the relative abundance of different species making up the richness of an area. It can be calculated as relative abundance is equal to number of individuals of species over the total number of species. Again, let's use the example of the flower species counts from two communities. So, same flower species and same number of individuals for community 1 and 2. Simpson's Index of Diversity. So, this formula is a measure of diversity which takes into account the number of species present as well as the relative abundance of each species. As species richness and evenness increase, so diversity increases. The value of D ranges between 0 and 1. Simpson's Index Scale Level of Diversity. Okay, this table shows the scale of the Simpson as well as the level of diversity on each scale. If the scale of index is 1, it signifies that there is no diversity. Scale 0.9 to 0.99, extreme low diversity. 0.8 to 0.89, very low diversity. 0.7 to 0.79, low diversity. 0.6 to 0.69, moderate low diversity. 0.5 to 0.59, moderate diversity. 0.4 to 0.49, moderate high diversity. 0.3 to 0.39, high diversity. 0.2 to 0.29, very high diversity. 0.1 to 0.19, extremely high diversity. 0, which is infinite diversity. The the Simpson's Index of Diversity formula. Okay. D is equals to 1 minus the summation of n times n minus 1 divided by n times n minus 1, where n is the total number of organisms of all species and the small n is the total number of organisms of a particular species. Take note that the greater the value of D, the lower the diversity. The lower the value of D, the greater the diversity. Example, we have 4 species of flower: dandelion, buttercup, daisy, and marigold. The number of species for dandelion is 72, buttercup has 23, daisy has 19, and marigold 18, with a total of 122 species of flower. Okay, so how did you get this number? It says n times the n minus 1. So for dandelion, you have to do is 72 times 72 minus 1 is 71. So 72 times 71 is 5,112. For buttercup, you have 23 times 23 minus 1, which is 2, 22. So 23 times 22 is 506. Next, for daisy, 19 times 19 minus 1, which is 18. 19 times 18 is 342. And 8 times 8 minus 1, which is 7. 8 times 7 is 56. Now, get the total or the summation of n times the n minus 1. 5,112 plus 506 plus 342 plus 56 is 6,016. Okay, another number that you need to find is the capital N times capital N minus 1. So we have here the capital N, which is equivalent to 122. So 122 N multiplied by n minus 1, which is 122 minus 1 is 14,672. Using the Simpson's Index of Diversity formula, which is D is equals to 1 minus the summation of n times the n minus 1 divided by capital N times n minus 1, we are going to substitute the value that we have computed earlier. For summation of n times n minus 1, we are going to put 6,016. And for the capital N, n times the n minus 1, which is equivalent to 14,672. So 6,016 divided by 14,672 is equivalent to 0.41. 1 minus 0.41 is equal to 0.59. The value of D is equals to 0.59. So what is the level of diversity? Moderate diversity. Population density formula. To calculate the population density, you will divide the population by the size of the area. Population density, or PD, is equal to the number of people or species over land area. Take note that the unit of the land area should be square miles or square kilometers. Here is an example of a population. So you'll notice that there are 3 different shapes of different colors. In the legend, you will see the yellow circles represent Bermuda grass, the blue square represent the lilies, and the red triangles represent the clover. Let's try solving the population density of the clover. Clover here is the red triangle. So population density of clover is equal to number of species divided by the land area. To get the number of species, count the number of the red triangle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 21. And we have 21 species. Then the land area is 0.18 kilometer times 0.2 kilometers. In the diagram, you will notice that there is 180 m or 180 meters and 200 meters. So when meters is converted to kilometer, 100 meter is equivalent to 0.1 kilometer, or you need 1000 meter to have 1 kilometer. 180 meters is equivalent to 0.18 kilometers, and 200 meters is equivalent to 0.2 kilometers. Then multiply the land area to get the square. So 21 over 0.18 times 0.2 is 0.36. Kilometer times kilometer is equals to square kilometer. Then divide the number of species by the land area. 21 divided by 0.36 kilometers squared is equals to 58.33. Therefore, the population density of the clover is 58.33 clover per kilometer square. Okay, so let's try solving the population density of the Bermuda grass and the lilies. Okay, so following the same formula, count the number of species for Bermuda, 57, then same land area, so that will be 0.36 kilometers square. 57 divided by 0.36 kilometers square is equals to 158.33 kilometers square. Therefore, the population density of the Bermuda, 158.33 Bermuda per kilometer square. And for the lilies, okay, the number of lilies in this diagram is 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. The one behind that blue square, so 16. Same land area, therefore it is 0.36 kilometers square. 16 divided by 0.36 kilometers square is equals to 44.44. Therefore, the population density of the lilies is 44.44 lilies per kilometer square. If you get the same answer, then good job. Okay, so that ends our discussion for today. I hope that this video gives you a lot of knowledge about biodiversity or the population density. So this is The Scientific Mind with Sir Eman, and I wish you a good weekend.